All right, so I'm thinking of two numbers. When I add them together, I get a sum of 12. When I subtract them, I get a difference of 6. What are the numbers? Go ahead and pause the video. See if you can figure out what these two numbers are. When you're ready, press play, and we'll check. All right, so when I add them together, I get a sum of 12. So that means if I were to add two numbers, they have to add up to 12. When I subtract them, I get a difference of 6. So when I subtract them, it's 6. So we can just start with, guess and check. Were there two numbers that add up to 12? Well, 6 plus 6 is 12, but 6 minus 6 is 0. So it's not that. Let's see what else. Let's see, 10 plus 2 is 12. But if I subtract 10 minus 2, I get 8, not 6. So it's not that. So hopefully you found that the correct answer is that when you add 9 plus 3, you get 12. And when you subtract 9 minus 3, you get 6. The larger number is 9. The smaller number is 3. Now what we have here is really an introduction to systems of equations, also called linear systems. When we are adding two unknown numbers, that's like adding two variables, rather than leaving them as blanks, I could have said x plus y equals 12, and x minus y has to equal 6. When we put that together, this is a linear system, a system of linear equations that has one solution with two numbers in it. It's a very unique solution. So our topic today is the graphing method for solving linear systems. So our question today, how do I solve a linear system using the graphing method? Let's start by looking at what is a linear system. So in our preview, we saw a linear system is when you have two or more equations that have the same variables, and they happen to be linear equations. So here's an example. And whenever we have linear systems, we always have this little, it's called a brace, called a bracket sometimes, but it's technically called a brace on the left-hand side, grouping the two equations together to show that it's really one system, not two separate pieces. So together, this system could have one solution, where the x value from the first equation has to be the same x value in the second equation. The unknown y value in the first equation would have to be the exact same y value in the second equation. So if we were to think of a number, so an x value, and when we add 4, it gives us a y value, we'd want to find the same x value that when we multiply it by -2 and add 1, it gives us the same y value as we got in the first equation. If we can find that x and y, that's the solution to the system of equations. So a solution is that ordered pair, that x and y value that makes each equation true. Okay, and it's important to note, I can't have two different x's. I can't say x is 5 up here and 7 down here. All right, the x within the system, the x has to be the same in each equation, the y has to be the same in each equation. And that's the trick, is trying to figure out what combination of x and y would make both equations true at the same time. So here's an example where we have a linear system, and I'm not showing you how to solve this system just yet, but what I'm showing you is if we have this linear system, can I check to see if this ordered pair is a solution or not? And the answer is yes, you can. It's just like checking an answer to any equation. We substitute our values for x, which is 1, and y, which is 5, into both equations. Now the trick here is that it has to work in both equations. So I take the system and I put the first equation on the left, the second equation on the right. And my first step is I'm going to substitute my value for x, which is 1, into both equations where x is, and I'm going to substitute my value for y into both equations where the y is. Now when I do that, I get this. My first equation, instead of 2 times x minus 3 times y, I get 2 times 1 minus 3 times 5. In my other equation, instead of just x plus y, I have 1 plus 5. I do a little math, so I'm going to evaluate both of these. And on the left-hand side, I get 2 minus 15, which is -13. And we look at this. Does it make it true now? Does the left side equal the right side? Yes, it does. So I put a little check mark there. Now, that alone is not enough to say that 1, 5 is a solution to the system. It's enough to say it's a solution to the first equation, but in order to be a solution to the entire system, it has to work in all of the equations. So let's check over here. We substituted in our values for x and y, and we got 1 plus 5 equals 6, which is also true because 6 equals 6. So 1, 5 was the solution to the first equation. 1, 5 was the solution to the second equation. So 1, 5 is a solution to the system. Okay, so the key there is that this ordered pair must be a solution to both equations or all equations within the system to be considered a solution to the whole thing. So let's talk about how to solve. Now that we know how to tell if an ordered pair is a solution, we're going to use the graphing technology to do our solving. But what we're going to do is we're going to graph both of these equations. We're going to use Desmos to do that. And what we're looking for is we're looking for the one x and y value that they have in common. We're looking for that one ordered pair that these two things will have in common. I want you to think about, what does it look like when I graph an equation? Well, if you remember from Unit 1, when we graph linear equations, we will get a line. Now, if I graph two linear equations on the same graph, I'm more than likely going to get two straight lines. I should grab the line drawer. I have one line, let's see, one has a negative slope, so that's going to go down. I have one that has a positive slope, that's going to go up. And I want to know, where do these two equations have a point in common? Where is that x and y that they share? So what we're looking for is that point of intersection, the point where the two lines meet. That point has a name. It's an ordered pair. So our solution, the point they have in common, is written as that ordered pair on the graph. So let's actually do that using Desmos. All right, so here we have our graphing calculator. And what I need to do is I need to type these equations into my equation editing area. Just type them as exactly as you see them. Y equals negative 2x plus 9. I see I have a red mark to the left of that, and I see I have my red line on the graph. And my second equation, y equals 2x minus 7, I see that I have a blue mark here, and I now see I have a blue line on my graph space. Now with Desmos, you can kind of move this around. You can zoom it in or zoom it out. You can press the house button if you want to recenter your screen so the origin's in the middle. You can even go ahead and hide equations if you have too many things up here at once. But I want to see the entire system of equations on the graph. And I want to go ahead and zoom this in, because what we're looking for, if you remember, is we're looking for the point of intersection. The one ordered pair that these two lines have in common. And the only thing that these two lines have in common is right here where the two lines intersect. And our two lines intersect at the ordered pair 4, 1. So 4, 1 is our solution. 4, 1 solution. Let's take a look at another example. Okay, this time we have an equation, a system of equations that have some fractions in there. So I just want to remind you that you can still graph this. I would always encourage you to clear your screen, go to new blank graph. And when you type in fractions, you're literally just going to type 1/3. Okay, so you press the numerator, and when you press the slash button, which is down by the right shift key, it turns it into a fraction automatically, and you can type in your denominator. Now, you do have to make sure that you move out of the denominator before you press X. So you just press to the right on your keyboard, or I believe you can just click off to the side of it before you insert your X. So notice X isn't on the bottom, it's not 3X, it's 1/3 times X. And our equation ends with +4. So that's my red equation. My second one I type in, y equals 1/2. I move out of the denominator before I press my X, and I have +3. I double check and make sure both equations are correct. That's the biggest thing you have to do when you're using technology, is make sure you're graphing what you're supposed to be graphing. And let's take a better look at this. I can see my two lines and I'm looking for the one point they have in common. That's where my solutions are. So I zoom in to where those two lines meet. And if I click that point, it stays where I can see it. It's x is 6 and y is 6. It's the ordered pair 6, 6. So if we were to check that, taking 6 in for x, 1/3 of 6 is 2, and 2 plus 4 is the y value of 6. And if I check it in my second equation, half of 6 is 3, and 3 plus 3 is 6. So when x is 6, y is 6. Makes both equations true. So I write my answer as an ordered pair. All right, not too bad, right? When you have graphing technology, it actually makes it quite simple. Now, what I want to focus on is more, how do we apply this to real life? The BHS Math Club needs to rent a bus for a field trip. There are two different bus companies. Main Street Buses charges a $40 rental fee plus $2 for each mile. County Bus Line charges a $20 rental fee plus $3 per mile. So Main Street buses, they charge a lot more up front. Just to rent the bus, you got to pay $40. County Bus Line only charges $20 for that rental fee. So, Main Street buses, they're going to get more up front right away. However, the further the trip, the more you're going to have to pay for County Bus Line because they charge $3 for every mile, where Main Street buses only charge $2 for every mile. So that's where we kind of see this difference here. If you have long trips, it might be better to go with the Main Street buses because it's a lower price per mile. If you have a shorter trip, then the charge per mile isn't quite so bad. You really get hit with the rental fee, so you want the lower rental fee. So we're going to use this to try to figure out for what number of miles will the total charge be the same, and what will that charge be? So the first thing we want to do is take our information and write a system of equations. So one part of the equation is the rental fee. Oops. The other part of the equation is the charge per mile. And when we write our equations, we have to think about what our variables are. Okay, well, we have x, which is going to be the number of miles. That's the one thing we don't know here. How many miles are you going to go on your field trip? And then based on the number of miles, we would use that to calculate the total cost. So let's think about the first company, Main Street Buses. Okay, so how do we find the total cost for Main Street Buses? Well, it's a $40 rental fee. So for each trip, it's just $40, whether it's 1 mile, 10 miles, 20 miles, 100 miles, whatever it is. It's just $40 to rent plus $2 for each mile. So we write that as 2 times X, which was the number of miles. For the county bus line, we have a total cost. That's $20 for the rental fee plus $3 per mile. So when we put that together, that's our system of equations, where X represents the number of miles and Y represents the total cost. Let's use Desmos to graph our two equations. I'll clear my graph, see my equations. Y equals 40 plus 2x, that's $40 rental fee plus $2 per mile for the first bus company. And the second bus company, y equals 20 plus 3x. Now I only see my blue line here, so let's make this bigger and maybe zoom it out. Let's see, oh, there it is. Okay, so I found it. I can see my lines are getting closer together as I move up here. I want that point of intersection, which is at 20, 80. All right, so our solution to this system was 20, 80. And we have to think about, well, what do those numbers represent? All right, 20 was the X value because it's first. So that means it's 20 miles. So when both bus companies reach 20 miles, the Y value, or the total cost, is $80. So that's when both companies end up being the same. So for what number of miles will the total charge be the same? Well, let's see, number of miles is your x value, so that's 20. We always do labels when we do real problems, applications. 20 miles. So what will that charge be? In other words, what's the total cost for 20 miles? $80 based on our y value. So that's how we can use a system of equations, solve it by graphing, to be able to interpret our solution.